Good day! So for today's video, I will explain to you about the Journal in Aquaculture from Volume 563, Part 2, January 30, 2023, page 738 to 949, in short communication of acoustic environment of aquaculture net pens varies with feeding status of Atlantic salmon or salmosalar, by the author of Caroline M. Rosten. So, continuous data on the condition of fish is necessary to monitor, control, and document biological processes in fish farm in real time. Yet, acquiring it from a large net pen environment is challenging. Tools to rapidly detect change in the entire net pen population are lacking. Automated passive acoustic monitoring is emerging as an effective monitoring tools in wildlife monitoring but has not before been tested in an aquaculture settings. Here, we explore the possibilities for passive acoustic monitoring in an aquaculture perspective. We investigated whether the soundscape of a net pen could infer information on the condition of the whole net pen population. So, yung continuous data on the condition of fish is kinakailangan upang masubaybayan, makontrol, and madocument natin yung mga biological processes ng fish farm in real time. Ngunit, ang pagkuha nito mula sa isang malaking net pen is mahirap. Then, yung automated passive acoustic monitoring is umuusbong bilang isang epektibong tools sa pagsubaybay sa wildlife monitoring. Ngunit, hindi pa din ito nasusuri sa isang setting ng aquaculture. As fish farming becoming increasingly industrialized, the industry is looking towards application of emerging digital technologies and automated system. Continuous data on the condition of the fish is necessary to optimize existing and new operational procedure or management regimes and ensure knowledge-based productions. To achieve this increased application of emerging technologies and automated system is needed. Real-time surveillance are already identified by the aquaculture industry as a key, offer a large step forwards in achieving knowledge-based production. Several approaches has been identified and tested, including visual methods, individual-based biologger, and telemetry methods. However, observing sounds by monitoring the soundscape of a net pen has not yet been considered. Conserving sounds made by animal offer potential for monitoring large group of animals non-invasively, or fish make a varied range of sounds and kasumyan, and a recent study of confirmed sound production in salmonid species. So, dito naman, tinitingnan ng mga industriya ang mga application ng mga umuusbong na digital na teknolohiya at mga automated system. And ang tuloy-tuloy na data ng kondisyon ng isda is kinakailangan para ma-optimize ang mga umiiral at bagong operational procedures or management regimes, and matiyak natin yung mga kaalaman based on production. Then, yung real-time surveillance or yung real-time na pagsubaybay is natukoy or nalaman na ng industriya ng aquaculture bilang isang susi. Then nag-alok na ito ng malaking hakbang pasulong sa pagkamit ng production na nakabatay sa kaalaman. Maraming mga diskarte ang natukoy or nasubok, kabilang ang mga visual na pamamaraan ng individual na nakabatay sa biologger at ng mga pamamaraan ng telemetry. Two types of sounds can be made by fishes, active and involuntary. Active sounds can be considered as those made for communication, for example, during agonistic interactions, courtship, spawning, speeding, schooling, and in distress situations, while involuntary sounds are those that arise during other activities. Hydrophone deployment. Audio recording were made at fish farm in 2 locations. This data was used to tackle our 3 research questions, addressed as 3 separate cases. Denote Case 1, Case 2, and Case 3. Case 1 compared recording from the net pens with and without salmon. Case 2 compared the peak frequencies at different depth, and Case 3 compared soundscape features during and post-feeding. Case 1 recording were made at Corneset located in Cornes, Jordan at Halsa, Norway between 11th and 12th November 2020. Case 1 involved the simultaneous deployment of 2 hydrophones for 24 hours. One was deployed at 6 m depth in a net pen with Atlantic salmon. The other was deployed in the similar manner in an identical net pen, without fish 120 m away from the purse. To record ambient noise in an empty net pen, the hydrophones for case 1 were moored as shown in figure 1, but with only a single hydrophones mounted in position H4. The buoy was secured with ropes in two places at the net pen floating collar. The ropes were placed so that the buoy floated 3 m inside the net pen. So, dito naman, yung audio recording is ginawa ng fish farm sa dalawang locations. Then, ginamit ang data na ito upang matugunan yung tatlong tanong na pagsasaliksiks na tinutugunan ng tatlong bilang na magkakahiwalay na case or yung kaso. Ito yung case 1, case 2, and case 3. So, inihambing ng case 1 ang mga pag-record mula sa mga net pen na meron at walang salmon. And yung case 2 naman is nagkumpara ng mga peak frequencies sa iba't ibang lalim. Then, yung case 3, inihambing or pinagkumpara naman dito yung feature or soundscape habang nagpapakain hanggang sa matapos ng pagpapakain. Kasama sa case 1 yung sabay-sabay na pag-deploy ng dalawang hydrophones sa loob ng 24 hours. And yung isa ay na-deploy sa lalim ng 6 meter or sa isang net pen na may Atlantic salmon. Ang isa ay na-deploy sa katulad na paraan na isang magkaparehong net pen na walang isda. 120 m ang layo mula sa una upang magtala ng ambient noise sa isang walang laman na net pen. And yung mga hydrophones para sa case 1 is nakamoving tulad ng ipinakita sa figure 1. Ngunit may isang solong hydrophones lamang ang nakamount sa posisyon ng H4. Loosely secured transmission of sound from the vibrations of the cage structure of audio recording. The hydrophones were mounted horizontally facing inwards towards the center of each net pen. Then figure 1, the hydrophones vary as configuration and right replacement in the fish cage in case 2 and case 3. Case 1 used the same rig, but with a single hydrophones play in a position H4. The rig has the place in the net pen in the same way as for case 2 and case 3. The circumference of the fish cage was 157 meter or radius of 25 meter. The net consisted of vertical cylindrical wall and conical bottom. So, dito sa figure 1, ginamit ng case 1 ang parehong rig, ngunit may isang hydrophones lang ang inilagay sa posisyon ng H4. Ang rig ay inilagay sa net pen sa parehong paraan tulad ng para sa case 2 at case 3. Ang circumference ng mga fish cage ay 157 m, radius na 25 m. Ang lambat ay binubuo ng vertical cylindrical wall at isang conical bottom. Data analysis. So, case 1 addressed the research question of whether the acoustic environment of a net pen with salmon differ from that one of the empty net pen. Here, representative data from 1 hour of the recording periods between 1,400 and 1,500 each CET was used for analysis, statistical treatment, and additional analysis for the entire 22. Each period is represented in the supplementary materials. In case 3, the post-process spectrogram was assessed over a longer period, from 1,200 HCET on September 1, 2020 to 1,000 HCET on September 2, 2020. In order to investigate temporal variation, feeding was ongoing at the time the recording started and stopped at 1,700 HCET on September 1, 2020. There was no feeding on September 2, 2020. Peak frequency during a single hour with feeding 1,400 to 1,500 HCET was compared in more detail to a single hour without feeding 1,700 to 1,882 CET. In all cases, the recorded audio was analyzed by first computing in the spectrogram and then post-processing the spectrogram to suppress and ambient noise and intermittent loud noises so as highlight the sounds of interest. So, sabi dito, ang case 1 is tumutugon sa pananaliksik na tanong kung ang acoustic environment ng isang net pen na may salmon ay naiiba sa isang walang laman na net pen. Dito, ginamit ang kinatawan na data mula sa isang oras ng panahon ng pag-record sa pagitan ng 1,400 at 1,500 HCET para sa pagsusuri. Ang paggamot sa isang statistika o karagdagang pagsusuri para sa buong 22 hours sa panahon ay ipinakita sa at pandagdag na material. In result, post-processing of the spectrogram successfully suppressed background noise such as feed spreading at the surface and movement of net pen structure underwater, enabling sounds within the net pen to be highlighted. The acoustic environment of the fish farm varied both partially inside-outside through a 24 period and during feeding versus non-feeding. Case 1 addressed the question of whether the differ from that of an empty net pen. The net pen is slightly below 400 HC, which was absent in the net pen without fish figure 2, referring to the supplementary materials statistical treatment of the entire 24H period for case 1 support this observation and shows a consistent significant P less than 0.05 difference between the net pens with and without fish in the frequency range from 200 to 800 Hz. Figure 2. Time average and smooth post-process spectra comparing relative sounds intensity level between 50 and 5 percentiles from a 1-hour audio recording demonstrating sounds in the net pens 120 m apart with approximately 200,000 fish and without salmon. Case 2 address whether the acoustic environment of a net pens represents surface underwater sounds or a combination. The frequently distribution of the recording 20 m outside the net pen at 3 m different noticeably from those at 4 to 5 and 6 meter. Case 3 investigated whether the acoustic environment of net pen varies with feeding status of the salmon using the recording at 6 m depth. In discussions, presence of Atlantic salmon changed the acoustic environment in the net pen in particular frequencies in the range of 300 to 500 Hz were of higher intensity in the presence of salmon in figure 2. Pattern in soundscape feature could not be attributed solely to net pen structures. Example, net moorings or external sounds in the marine net pen block the frequency observed in the net pen with salmon. Surface noise quickly diminish below 3 m depth in a recording take in 2 m outside the net pen in figure 3, meaning that the soundscape used in our analysis consisted predominantly of underwater sounds. Figure 3. Time average and smooth post-process spectra comparing relative sounds intensity level between 50 and 51 percentiles at depth of 3, 4, 5, and 6 m approximately 20 m outside and net pen with salmon. The spectrogram varied over time throughout case 3. Figure 4. In particular, the sound intensity, peak frequency, and how broad the spectrum was. The net pen environment varies during the dial cycle due, for example, change in daylight current, strength and direction, and human activity and operations. Example, boat activity on site. The status of the fish also varies over time due, for example, to hunger status or circadian rhythm. Variation in the dynamics and activity patterns of Atlantic salmon is well documented in net pens. In figure 4, post-process spectrogram showing change in the soundscape during and after feeding in the net pen on September 1 to 2, 2020. Highest sounds intensity level are shown in the yellow while lowest are dark blue. For interpretation of the reference to color in this figure legends, the reader is referred to the web version of this article. Then, in figure 5, time average and smooth post-process spectra comparing relative sounds in intensity level between 50 and 51 percentile, illustrating feeding and non-feeding periods in the net pen with approximately 180,000 Atlantic salmon on September 1, 2020. So, this study has demonstrated that passive acoustic monitoring has potential for providing valuable complementary information on the status of production fish in aquaculture facilities. We provide first evidence that Atlantic salmon, salmosalar, alter the acoustic environment change, which can be detected at the net pens scale and demonstrate, and variation in sounds mirrors the food-seeking status of the fish. further research, including longer period of recording to include difference environmental condition, fish treatment, and production space will enable greater understanding and potential application of the net pen soundscape. Following further research, soundscape monitoring may become a valuable tool in the fish farmers to toolbox for real-time surveillance of the net pen.